Hi everyone. Let us see today's problem of the day, that is remove methods from project. You are maintaining a project that has n methods numbered 0 to n minus 1. Okay. You are given two integers n comma n and k and a 2D array invocations where invocation A is to be indicate that method A invokes B. So basically A will have an error to B. There is a known bug in the method K. Method K along with any method invoked by it either directly or indirectly are considered auspicious suspicious, and we aim to remove them. The group of method can only be removed if no method outside the group invokes any method within it. Return any array containing all the remaining methods after removing all the suspicious methods. You may return the answer in any order if not possible. Okay, so basically let me simplify this. What it is saying is that we will be given some nodes, let's say 1 2 3. Let's say it can be a directed DAG or a directed cyclic one, it can be. And let's say if this second node is corrupted, then all the nodes that can be traversed from second to third will be corrupted too. This will be also corrupted, and we have to output the nodes that are not corrupted. So ideally in this case answer should be 1 4 and 5. These nodes are not affected by 2, correct? But the thing is, there is an additional condition that we can remove a node only if any non-corrupted node is not pointing to uncorrupted node. So this is corrupted and this is non-corrupted and it is pointing to this. So that's why this 2 can't be removed, and 3 and hence 3 can't also be removed. So 2 and 3 will be answer for this one. Yeah, so this is the pretty much that problem is asking from us. Now let us see the approaches. Brute force I think will work over here, because as we can see, first of all we have to basically mark two things. First is the marking the corrupted nodes, and second is the checking if there is any edge from non-corrupted node to a corrupted node. We have to just check this. So marking all corrupted node will be a DFS simply, and then we need to use basically visit all non-corrupted nodes, and from there check if any of these nodes are pointing to any corrupted node. Okay, so yeah, we can try the implementation for marking. So basically I think we need to maintain two states here, one for the viz state and other can be for marking these nodes. Viz state will tell me that a particular node has already been processed, or we can use this simply the correct and then out of non-visited nodes we have to check if those are pointing to any corrupted node. Let us try. Since n will be node, so let me do this. Let me create two arrays of boolean that will first of all will be the visited one. Those will be marked as false, and the second one will be corrupted node is corrupted or not. That will So initially no node is corrupted, and we will also be needing the adjacency list in order to traverse this graph, right? So I will be making this out of a map, unordered map of int comma vector of int, correct? So let me now traverse this I equal to 0, I equal to invocations dot size, then I plus plus, and see if so edge will be going from A to B. A will be my parent and B will be my the child. Invocations of I comma 0 dot push back invocations I comma 1. So these will define the edges. Now that is done, right? Now let us try to mark corrupted nodes, and that will take, of course, my adjacency list. That will take also the kth node, and that will also mark the visited ones, and that will also update is corrupted node is corrupted or not. So once those are done, then we need to kind of perform for int I equal to 0, I less than n, and I plus 1. We need to basically check from all non-corrupted nodes if any of those are marking to an corrupted node. So we will basically need to run a DFS. If first of all we need to check if it is not visited, that is the first thing, or visited, it is not visited, and so visited will already be taken out of this. Then we can invoke DFS using this adjacency list, and we need to pass this is corrupted node, and we need to pass our visited one, and if any of these are if any of these node basically points to any corrupted node, then it will be return false, or basically we have to return the original nodes, correct? Nothing can be removed, so nothing can be removed, return the full array. So okay, we need to we will return the all nodes, right? And if that doesn't happens, then we will traverse, or we will use a boolean flag so that we don't have to do it again and again. All nodes true or false. We will do all nodes as true. We will need to, and we will break this loop, and we will do something like this: I less than n, I plus plus. If all nodes is false, means all nodes need not to be corrupted, and this corrupted has marked this node, this particular node then we need to just continue, otherwise result dot push back ith value, return result vector of int comma result, right? Now marking this node, that will be an important function. How are we going to do that? Let me check. Since video was going to be long, was getting long, so I implemented these two functions, and yeah, let me explain this. So in mark corrupted node, we are just basically making a simple DFS call, marking every node whenever it is entering any recursion stack, and we are marking it as is corrupted true as well, and we are simply traversing to its child, visiting every non-visited node yet. Once that is done, I have implemented another DFS function. So whenever our DFS is false, basically, then all node shouldn't be printed. Then all nodes should be printed, because corrupted ones can't be eliminated. So for this DFS, we have just marking simply visited true and checking for every of its child if any of the node is corrupted or not. If it is corrupted, then check will be false. Check will be false, it will enter this. Then all nodes can be printed. If check is true, it won't enter this. So let us see. Let me run. How will this come up? Yeah, there can be some issues as well. Unordered map is there, adjoin is there. What's the issue? Identifier X, auto X. I have now auto X fine, I think, I guess. Okay, my bad. This, since what is X? X is not defined, right? So it should be shows. Yeah. No variable conversion into another map. 1 second. 25. Okay. Yeah. Here the order is changed. Adjoin of this. Adjoin, then S, then visited. Adjoin, then S, then visited, then is corrected. This is the order I am passing. I'm taking and putting. Yeah, so looks like this will work. Let me try to simulate this as well. There might be some corner cases. Let us see, but I think we should be able to handle stack overflow. So what is the, I think memory constraint might be the issue here. Yeah, so invocation length is 2 raised to power 5, and we are kind of running for every case. Correct, we are kind of here we are only checking on basis of is corrupted. We also need to put and check is corrupted is fine, and then if it is, even if it isn't corrupted, then it should also not be a visited one. We must this check. If that is not visited, then only we will take check for that element. Otherwise, yeah, it will keep going in the loops. Visited was fine. So let us see whether this really has come up. For 10 raised to power 5, what will be the time complexity for us? It is visiting every node, and then One optimization that we can make here is as soon as this check function, um, we can simply break this actually like this. If DFS from any of my child call is false, it is false, then simply return false. We don't need to even wait for this, right? Why do we need to check for other elements? We shouldn't be. And if it is passing every child, then only it can go ahead. We can do this, I think so. Let me try to use this test case and run this. These are some minor optimizations that might help. There might be something that we are really missing. We try this recent sign. Let me try. Basically it has to be passed by reference, I think so. Yeah, that will work. Yeah, so earlier we passed this by values, and that was the wrong thing. We have to pass it by reference. Yeah, so pretty much this one is also easy, just the implementation part. Yeah, thank you. Let me know your feedbacks, please. Thank you.